Hello, and welcome to Course 6 of Oregon's Third-Party Verification Training. This course provides an overview of verification for petroleum and natural gas systems reporting to the Greenhouse Gas Reporting Program. For any questions related to this training program, please contact us at 3pverify@deq.oregon.gov. My name is Stephanie Summers, and I am a reporting specialist for the Greenhouse Gas Reporting Program, focusing on the fuel suppliers and natural gas sectors. During today's training, we will start with a very brief overview of the natural gas infrastructure in Oregon. Then, we will walk through the reporting requirements laid out in our greenhouse gas reporting rules and take a closer look at the emission sources that must be included in segments that will likely require verification services. We will close with some quick tips on what to look for during the verification process and an example to apply some of the concepts we cover today. Before we jump into the training today, I wanted to share where to find supplemental materials and other helpful resources for this course. Acronyms and definitions relating to natural gas systems are available in Handout 1 for this course. There are also several materials on our website that are helpful to review in order to better understand how the Greenhouse Gas Reporting Program expects to receive the reporting for this sector. Please take time to review these, as you will need to be familiar with them to verify these regulated entities. We will start with a brief overview of the petroleum and natural gas systems sector. The first thing to note is that Oregon has no oil production, so we can focus solely on the natural gas side of this reporting. Oregon has minimal natural gas production and no processing facilities, so most of the natural gas is imported on one of the two large interstate pipelines that run through the state, TC Energy's pipeline and Williams Northwest Pipeline. There are three local distribution companies that supply gas within the state: Northwest Natural, Cascade Natural Gas, and Avistacor. Northwest Natural also operates an underground storage facility in Mist, Oregon, which is northwest of Portland, as well as liquefied natural gas storage facilities in Portland and Newport, Oregon. Now let's get into the reporting requirements. This slide provides a list of the key regulatory provisions for the Greenhouse Gas Reporting Program and third-party verification relevant to natural gas systems. We will touch on some of the key rules during this training, but you should review these regulations prior to the exam. All greenhouse gas reporting rules are found in Division 215 of Chapter 340 in the Oregon Administrative Rules. You will find general reporting requirements in Rules 10 through 60 and specific requirements for natural gas systems in Rule 125. OER 215 references methodologies in 40 CFR 98. It's important to note that while Oregon has adopted 40 CFR 98 subpart W, we have not adopted the most recent updates to that subpart of the regulation. Reporting should use the methodologies found in 40 CFR Part 98 subpart W as published in the Federal Register on December 9, 2016. Oregon still uses the AER4 global warming potentials to calculate those emissions. Companies must submit the reporting in the Your DEQ online system. Reporting in this format has been available for petroleum and natural gas systems since 2023. The submission must include the DEQ reporting form for petroleum and natural gas systems. This provides detail on how emissions were calculated. DEQ's reporting form is preferred. However, entities can submit the EPA's Subpart W reporting form instead. Regulated entities can also submit their own form that contains the calculations, but these will require more scrutiny by Oregon DEQ and are not preferred. The deadline for petroleum and natural gas systems emissions reports is March 31st. At this point, verification activities can begin, and verification statements must be submitted to DEQ by August 31st. Natural gas systems reporting is broken down by industry segment. Each segment listed here has specific emission sources to consider, monitoring and data requirements, and emissions calculation methodologies. The threshold for reporting emissions from petroleum and natural gas systems is 2,500 metric tons of CO2 equivalents during the reporting year, based on Subpart W emissions only. No combustion emissions from compressor stations are included in this threshold determination or reported under this rule. although we will see how those emissions are captured on the next slide. This threshold is calculated by facility, but the definition of facility is not always standard for this reporting. Importantly, a distribution facility includes all distribution pipelines and metering regulating stations operated by a local distribution company within Oregon. As a result, the 3 natural gas distribution companies in Oregon are required to report their distribution system emissions under this rule. If required to report in compliance with OAR 340-215-105, the facility must calculate any emissions for which there is an applicable methodology in 40 CFR Part 98 and report it with their stationary source emissions to the Greenhouse Gas Reporting Program. This means that stationary sources reporting to the Greenhouse Gas Reporting Program, because they have emissions of at least 2,500 metric tons of CO2 equivalents, are also required to report any subpart W emissions for that stationary source within that reporting. This rule requires that natural gas facilities, such as smaller compressor stations for underground or liquefied natural gas storage, report their subpart W emissions under the stationary source reporting sector discussed in Course 2. The threshold for third-party verification is emissions equal to 25,000 metric tons of CO2 equivalent, excluding biomass emissions. For natural gas system emissions reports, this threshold is calculated for all subpart W emissions within Oregon. It is not broken up by facility or industry segment. So, if a reporter had multiple facilities reported across multiple segments that were each below the verification threshold, but added together they exceeded that threshold, then all of the facility's emissions require verification. Given these reporting requirements and thresholds, let's look back at the industry segments and see which segments DEQ receives greenhouse gas reporting in Oregon for, and which of these emissions will require verification. Which of the listed segments are actually present in Oregon? Only about half of these segments are present within the state, and the emissions are small for many of them and do not meet the threshold for reporting those segments. So which of these are actually large enough that they will require third-party verification? Only 2, onshore natural gas transmission compression and natural gas distribution. Currently, we only have 2 facilities that will require verification in this sector, though they are all required to report emissions. Now that we've narrowed down what we're looking at, let's take a closer look at what greenhouse gas emissions reporting from these 2 relevant segments entails. We'll start with onshore natural gas transmission compression. Compressor stations are located every 50 to 100 miles on transmission pipelines, and you can see the locations of compressor stations along TC Energy and Northwest Pipeline distribution system on this map. TC Energy has 6 compressor stations, all of which are often above the emissions threshold for third-party verification. Northwest Pipeline has 7 compressor stations in Oregon, and you can see several more on this map just across the border in Washington. These are smaller and do not approach the reporting threshold. For those compressor facilities requiring verification, there are specific emission sources to consider under their subpart W emissions component. These are compressor venting, transmission storage tanks, blowdown vent stacks, pneumatic device venting, flare stack emissions, and equipment leaks. Petroleum and natural gas systems reporting under subpart W for compressor stations only includes emissions from leaks or venting at the facility. Combustion emissions, which will be the largest source of emissions from a compressor station, must be reported to the Greenhouse Gas Reporting Program as part of the stationary source emissions report using 40 CFR 98 subpart C methodologies. Those emissions are not included under subpart W reporting. For centrifugal compressor leak measurements, there are 2 options: as-found measurements or continuous volumetric flow monitoring. Measurements in either mode must be taken at the compressor vent or at the common vent stack of manifolded compressors. For a manifolded group, measurement can be taken from a single point in the manifold downstream of the compressor inputs. This measurement should occur before any commingling with other non-compressor emission sources, if possible. If emissions are routed to a flare, those emissions should be included in the emissions for the flare stack instead of under this emission source. For those using continuous volumetric flow measurement, where compressor blowdown emissions are included in the metered emissions, the emissions can be included under this emission source instead of being calculated separately using the methods for blowdown vent stacks. If using as found measurements, each compressor or manifolded group can be measured in either operating mode or depressurized mode based on what it is running in when measurements are taken. A developed emission factor from identical compressors at other sites that have measurements in the mode not measured must be used to calculate emissions from the compressor for any time it was operated in that mode during the reporting year. There are a few different methods to follow based on the mode the compressor is found in when surveying for leaks. For a centrifugal compressor being measured in operating mode, leaks from the blowdown vent and wet sealed oil degassing vent must be measured. For a centrifugal compressor measured in not operated depressurized mode, leakage from the isolation valve must be measured. Unless blind flanges are installed at the compressor, regulated entities using as found measurements must include a not operating depressurized mode measurement once every 3 years. If blind flanges are installed and the unit is not running during the whole reporting period, the compressor does not need to have measurements in the not operating depressurized mode. The second measurement method is continuous volumetric flow measurement. These measurements must be at standard conditions using a permanent meter. Where compressor blowdown emissions are included in the metered emissions, the emissions can be included under this emission source instead of being calculated separately using the methods for blowdown vent stacks. Manifolded groups of compressors should be measured downstream of all compressor inputs and prior to commingling with other non-compressor emission sources if possible. Reciprocating compressor measurements are similar, but there are a few differences in measurements that can be taken and where they are taken at. Reciprocating compressors won't have wet seals to monitor. However, rod packing must be measured for leaks when a reciprocating compressor is measured in operating mode. For reciprocating compressors, as found measurements may also take place in a standby pressurized mode and should be measured for leakage at the blowdown valve in that case. Let's move on to transmission storage tank emissions. Emissions from scrubber dump valve leakage must be monitored annually for leaks. If a leak is detected, the rate of emissions must be measured with a flow meter, optimal gas imaging, calibrated bag, or an acoustic leak detection device, and the emissions from the leak over the year must be calculated. Emissions must be calculated for venting to atmosphere or from flare emissions if routed to a flare. Anytime equipment is depressurized, that volume of gas vented to the atmosphere must be calculated at the blowdown vent stacks. These emissions can be quantified either with a flow meter on the blowdown vent stack or calculated based on unique physical volumes of equipment that is blown down. Any volumes that are routed to a flare should not be reported under this source type, but included under flared emissions. Blowdown vent stack emissions should be categorized by the type of equipment blown down. If an event covers more than one type, it should be categorized by the type that contributes the largest share of emissions. Any equipment with a unique physical volume of less than 50 cubic feet does not need to be reported under this section. Pneumatic devices are used to regulate liquid level in compressor scrubbers, gas flow, and pressure. They are also used to actuate isolation valves. Emissions from pneumatic devices are estimated by counting the number of continuous low, high, and intermittent bleed pneumatic devices at the facility and multiplying by an emission factor for each type of device. Flare stack emissions are calculated based on what type of monitoring devices are installed on the flare stack. If a SEMS is installed to measure flow and CO2 emissions, then this value should be reported using a Tier 4 calculation methodology from Subpart C. Otherwise, emissions for CO2, CH4, and N2O should be calculated using the equation shown here. Flow rate and gas composition data should be taken from the measured flow rate and composition data if available. If no instruments are installed, it is acceptable to use best available data to calculate the flow rate and composition. Make sure that emissions being included within this section are not double counted from other emission sources where those emissions have been routed to the flare. Fugitive emissions from leaking components at compressor stations must be surveyed at least once a year. Leak surveys must, at a minimum, check for leaks from valves, connectors, open-ended lines, pressure relief valves, and instruments or meters for both compressor and non-compressor components at the facility. Other components can also be surveyed, and certain other components may require surveys for other emission standards. If leaks are detected, emissions are estimated using a leaker emissions factor based on the component type. Leak detection can be done using optical gas imaging, Method 21, an infrared laser beam illuminated instrument, or an acoustic leak detection device. Note that there are additional survey requirements under Subpart Quad O if the compressor station was constructed or modified after September 18, 2015. In this case, leaks must be detected by optical gas imaging or a modified Method 21 that uses a 500 part per million leak detection threshold instead of 10,000 parts per million. Here are some general requirements for this section. For detected leaks, the start date of the leak is either the beginning of the reporting year or the date of the last leak survey that did not detect a leak. The end date of the leak is either the date the leak was repaired or the end of the reporting year. Each source has directions in the regulation on which emissions to calculate for different combinations of how compressors are set up and dependent on whether they have common vent stacks or are routed to flares and other variables. Not all of the detail on equations to use for each emission source is presented in this presentation. It is important to understand the rule and be able to find which equation the regulated entity should be using and if they are calculating the correct emissions based on the setup of their facility and the types of compressors they are using. Now moving on to the natural gas distribution segment. Here we have only two emission sources to consider: equipment leaks and combustion equipment. One important consideration in this segment is the definition of facility. The facility for a natural gas distribution system consists of the entire collection of distribution infrastructure within the state. Equipment leaks from natural gas distribution are calculated using both leak surveys and population counts. Surveys must be done for all above-grade transmission distribution transfer stations, with leaks detected and calculated for the 7 component types listed in Table W-7. These leak surveys can be performed over a multi-year period of up to 5 years, with a portion of all stations surveyed in each year. Data from these surveys is also used to develop an emission factor for above-grade metering regulating stations that are not transfer stations, which is then used as the emission factor in the population count for any above-grade metering regulating stations. Population counts are mainly used to estimate emissions from below-grade components that cannot be surveyed. This includes below-grade transmission distribution and metering regulating stations, which are categorized by pressure, and distribution mains and services, which are categorized by material. As noted in the last slide, emissions from any above-grade metering regulating stations that are not transmission distribution stations are also estimated by population count, using the calculated emission factor from the leak surveys at above-grade transmission distribution stations. If there are no above-grade transmission distribution stations, then emissions from the above-grade metering regulating stations do not need to be reported. Combustion emissions are reportable from any external combustion units with a heat capacity of greater than 5 million BTU per hour, or any internal combustion units with a heat capacity greater than 1 million BTU per hour. Units smaller than this do not have reportable emissions, but the distribution company must still report the number of each type of unit in use. The calculation to be used for emissions does vary here depending on the fuel type being combusted, but most fuels, particularly in the distribution segment, will use a fairly standard Subpart C methodology. The DEQ Subpart W form and the EPA Subpart W form have both been created to determine the emissions that must be calculated for each emission source. Entities fill out the form answering questions designed to capture the data required by this subpart. This is because the rule is complicated, there are different configurations used by different entities, and each can require different pollutant types to be measured and different equations to be used to calculate those emissions. Entities must use and upload these forms with their reporting, and they will be very useful to verifiers when they are reviewing the source. Verifiers should ensure that the forms are filled out correctly and that the correct emissions are being determined for the way that the company is set up. Because of the complicated rule, it is preferred that entities use either the DEQ form or the EPA form to calculate these emissions. However, entities may submit their own forms. Let's cover some tips for successful verification of this sector. Make sure that reported volumes have been converted to standard conditions. Things like blowdown emissions will have gas under pressure and need to be properly converted. Similarly, it's a good idea to check the calculations used for converting from volume to mass emissions and how mole fraction for the released gas has been calculated. Are these being done with a sample conversion spreadsheet that someone created 10 years ago, or do the individuals responsible for this data know what they are doing and why? Lastly, ensure that the reported leak time follows the regulation. If survey records can't show that a component was not leaking since the start of the year, then the leak must be assumed to go all the way back to January 1st. For identified leaks, check the maintenance logs for the repair date and time and make sure that it was properly tested to show the leak was fixed. The DEQ developed form has worksheets containing all of the information used to calculate the emissions that are shown in the reporting. It is important to review this form and ensure that all of the information is added correctly. If the entity is using their own form that they have created, it is even more important to review how the form works to ensure all of the emissions are being calculated correctly. Your verification plan should allow you to conclude with reasonable certainty that the emissions reported by your client are accurate. To achieve this, you will need to ensure you sufficiently verify the quantity of natural gas received by checking invoices, purchase records, and metering data. Ensure that all delivery locations are accounted for and that the data being used for reporting covers the entire reporting year. Don't truncate end months because of billing periods. Now we'll move into a reporting example to provide more practical examples of some of the information we've covered. As we go through the example, you may wish to pause the training to work through it on your own before proceeding to the solution. For this example, we will calculate the pneumatic device emissions from an onshore natural gas transmission compressor facility. The facility has 10 pneumatic devices that were operational for the entire year. All of the pneumatic devices are continuous low bleed. Assume the facility does not have specific data on gas composition for gas passing through the facility. Calculate the methane emissions from these 10 pneumatic devices. You can pause here to work through the problem on your own before continuing to the solution. To do this calculation, we need to know the emission factor for a low bleed pneumatic device, which is taken from table W-3B. Since no gas composition data was provided, we must use the default mole fraction for methane of 0.95. Plugging this into equation W-1, we get emissions of about 114,000 cubic feet of methane over the reporting year. Now this volume must be converted to mass. Here we use equation W-36 with the density of methane and also convert from kilograms to metric tons. And finally, in step 3, we convert from the mass of methane emissions to a carbon dioxide equivalent using a global warming potential of 25. That brings us to the end of this course. If you have any questions, you can contact our team at 3pverify@deq.oregon.gov. Thank you for watching.